In this class, we solve the problems of exercise 1.4. First problem. In the first problem, it is given that prove that the following are irrational. So there are 5 bits are given. We have to prove these are the irrational numbers. So first we solve the first bit. It is given that 1 by root 2. We have to prove that 1 by root 2 is irrational. To prove 1 by root 2 is irrational, let us assume 1 by root 2 is irrational. So we can write 1 by root 2 is equal to p by where p comma q are co-primes. We already know that co-primes means they not have any common factor other than 1. So 1 by root 2 is equal to p by q. Now we rearrange 1 by root 2 is equal to p by q by cross multiplying. Then we can write it as q by p is equal to root 2 by 1. This can be written as q by p is equal to root 2. In LHS, p comma q are co-primes, so q by p is irrational. In RHS, root 2 is irrational, so q by p is not equal to root 2. This contradicts our assumption 1 by root 2 is irrational. Therefore, we can say 1 by root 2 is irrational. We have to prove root 3 plus root 5 is irrational. To prove root 3 plus root 5 irrational, let us assume root 3 plus root 5 is irrational. So we can write root 3 plus root 5 is equal to p by q, where p comma q are co-primes. Co-primes means they not have any common factor other than 1. Next we can write root 3 plus root 5 is equal to p by q. By transposing root 5 to the RHS, we get root 3 is equal to p by q minus root 5. Now squaring on both sides. So it can be written as root 3 whole square is equal to p by q minus root 5 whole square. So we can cancel root and 2. Then it can be written as 3 is equal to p by q minus root 5 whole square. RHS is in the form of a minus b whole square, which is equal to a square plus b square minus 2ab. So we write the LHS in the form of a minus b whole square. So we can write next 3 is equal to p by q whole square plus root 5 whole square minus 2 into a means p by q, b means root 5. So now we can cancel root and square. After simplification we can write p square by q square plus 5 minus 2p by q into root 5. To simplify, we transpose the 3 to RHS and this term to the LHS. So we can write it as a 2p root 5 by q. Because here we have negative sign, so it will come to the LHS, it will become positive. So next, these two terms are same as t is p square by q square plus 5. So 3 is in LHS positive, it will become minus 3 when coming to the RHS. So we can write it as 2p root 5 by q is equal to p square by q square plus 5 minus 3 is 2. Here we record only root 5 in LHS. So next it can be written as root 5 is equal to p square by q square plus 2. Next it will become q by 2p. This can be further simplified and we can write it as p square by 2q square by q square q by 2p. So we can cancel 1q. So next we can write it as root 5 is equal to p square by 2q square. Denominator can be written as 2pq. So in this equation, in RHS, p square plus 2q square and 2pq are co-primes. P square plus 2q square by 2pq in RHS is rational. But we already know that root 5 in LHS is irrational. Therefore, we can write root 5 is not equal to p square plus 2q square by 2pq. This contradicts our assumption root 3 plus root 5 is irrational. Therefore, we can say root 3 plus root 5 is irrational. Now we prove that 6 plus root 2 irrational. To prove 6 plus root 2 is irrational, let us consider 6 plus root 2 is rational. So we can write 6 plus root 2 is equal to P by Q, where P comma Q are co-primes. We already know that co-primes means they not have any common factor other than 1. So to solve 6 plus root 2 is equal to P by Q, we transpose 6 to the RHS. So we can write it as root 2 is equal to P by Q minus 6. Next, root 2 is equal to P by Q minus 6 can be written as root 2 is equal to P minus 6Q by Q. In RHS, P minus 6Q comma Q are co-primes. So P minus 6Q by Q is rational. But in LHS, root 2 is irrational. So root 2 is not equal to P minus 6Q by Q. This contradicts our assumption 6 plus root 2 is rational. Therefore we can say 6 plus root 2 is irrational. Now we have to prove root 5 is irrational. To prove root 5 is irrational, let us consider root 5 is rational. So we can write root 5 is equal to P by Q. We'll write this one as a equation 1, where P comma Q are co-primes. We already know that co-primes means P comma Q not have any prime factors other than 1. So by using fundamental theorem of arithmetic, varying equation 1 on both sides. So equation 1 implies root 5 whole square is equal to P by Q whole square. So above equation can be written as root 5 whole square is equal to P square by Q square. We can cancel square root and 2, which can be written as 5 is equal to P square by Q square. Next we transpose Q square to the LHS. So it becomes 5Q square is equal to P square. Let this one as a equation 2. So from this equation we can say 5 is factor of P square. So by fundamental theorem of arithmetic we can say 5 is also factor of, then we can write P is equal to 2C. Then we can write P is equal to 5C, where C is any integer. Now substitute P is equal to 5C in equation 2. Then equation 2 implies 5Q square is equal to, in place of P we can write 5C, this whole square. So this can be written as 5Q square is equal to 5 square C square. So we can cancel 5 ones and here 1 5. So we can write it as Q square is equal to 5 C square. From this equation we can say 5 is factor of Q square. Then we can also say that 5 is factor of Q. From above we can conclude that 5 is factor of both P comma Q. This contradicts our assumption root 5 is irrational. So we can say root 5 is irrational. Now we have to prove 3 plus 2 root 5 is irrational. To prove 3 plus 2 root 5 is irrational, let us consider 3 plus 2 root 5 is irrational. So we can write 3 plus 2 root 5 is equal to P by Q, where P comma Q are co-primes. We already know that co-primes means P comma Q not have common factor other than 1. So 3 plus 2 root 5 is equal to P by Q can be written as, to solve 3 plus 2 root 5 is equal to P by Q transpose 3 to the RHS. So it can be written as 2 root 5 is equal to P by Q minus 3. Next above equation can be written as 2 root 5 is equal to P minus 3Q by Q. So above equation can be further simplified as P minus 3Q by 2Q. We transpose the 2 to the denominator of RHS. So we can write root 5 is equal to P minus 3Q by 2Q. In RHS, P minus 3Q, 2Q are co-primes because they not have any common factor other than 1. So p minus 3q by 2q is rational. But root 5 in LHS is irrational. This contradicts our assumption 3 plus 2 root 5 rational. So root 5 is not equal to p minus 3q by 2q. Therefore we can say 3 plus 2 root 5 is irrational. Now we solve exercise 1.4 second problem. In this problem it is given that prove that root p plus root q is an irrational where p, q are primes. To prove root p plus root q is irrational, we have to suppose that root p plus root q is rational. So we can write root p plus root q is equal to a by b, where a comma b are co-primes. We already know that co-primes means a comma b not have any common factor other than 1. Next to simplify, we transpose root q to the RHS. So above equation can be written as root p is equal to a by b minus root q. Let this equation as equation 1. Now squaring equation 1 on both sides. So we can write it as root p whole square is equal to a by b minus root q whole square. Here we can cancel root and square. So it can be written as p is equal to a by b minus root q whole square. So this RHS is in the form of a minus b whole square form. So we can write it as a square plus b square minus 2a by this. This is the formula we know. We can expand the RHS using this formula. By using the formula, we can expand a by b minus root q whole square as a by b whole square plus root q whole square minus 2 into a by b into root q. So in LHS, we can write p. So this can be written as a square by b square minus a root and square we can cancel. So we can write it as a q minus 2a by b root q. To simplify, we transpose p to the RHS and this total term to the LHS. So then we can write it as 2a by b root q is equal to a square by b square plus q minus p. Because we transposed plus p to the RHS, it will become minus p and this term is negative, so it will become positive to the LHS. Here we required in LHS only root q, so we transpose 2a by b to the RHS. So this step can be written as 2a by b root q is equal to, we take LCM, we can write it as b square and this can be written as a square plus b square q minus b square p. So we required in LHS root q only, so we transpose to a by b to the RHS. So we can write root q is equal to a square plus b square q minus b square p by b square. After transposition, 2a by b become b by 2a. Now we can cancel b and b. So we can write root q is equal to a square plus b square q minus b square p by 2a b. In RHS, a square plus b square q minus b square p and 2ab are co-primes. So they not have any common factor other than 1. So a square plus b square q minus b square by p, b square p by 2ab is rational. But in LHS, root q is irrational. So root q is not equal to a square plus b square q minus b square p by 2ab. This contradicts our assumption root p plus root q is rational. Therefore we can say root p plus root q is irrational.